Hello there, welcome to the sixth part of learning everything we can possibly learn from Apple's documentation. We are ready to learn about RealityKit and Reality Composer Pro, and the first thing we're going to look at is the Swift Splash, a sample code. We're going to use RealityKit to create an interactive ride in VisionOS. First, download the file, and while that's happening, let's take a look at the overview. Apple Vision Pro ability to combine virtual content seamlessly with the real world allows for many kinds of interactive virtual experiences. Swift Splash leverages RealityKit and Reality Composer Pro to create a virtual water slide by combining modular slide pieces. When the builder finishes the ride, they can release an adventurous goldfish to try it out. Here we go, let's take a look at Splish Splash. Here we have a little dome. This is the start point. We have a little goldfish in here. And we're gonna add a slide piece or two. Let's take a look at that. And we add a left turn and a loop, and we have a finish line. Once we have those items in order, we start the ride, and we are letting the goldfish run through its paces. As the goldfish bowl runs out of water, we send the fish down the slide, around the loopy-loop, and into the finish line. Those are really amazing animations, and I can't imagine being able to make that happen. So here we go. That is a very beautiful app. Let's look into it more deeply. So Swift Splash use multiple Reality Composer scenes to create a prepackaged entity hierarchy that represents each of the slide pieces the player connects to construct their ride. It demonstrates how to hide and review sections of the entity hierarchy based on the current states of the app. For example, for example, each slide piece contains an animated fish entity that's hidden until the ride runs and the fish arrives at that particular piece. While Swift Splash is a fun, game-like experience, the core idea of assembling virtual objects out of predefined parts can also be used as the basis for a productivity or a creative creation app. Swift Splash scenes include shader graph materials built in Reality Composer Pro to change the appearance of the ride at runtime. Each piece can be configured to display in one of three materials: metal, wood, or plastic. Other shader graph materials can create special effects, such as the movement of the water and the flashlights on the start and end of the pieces. Each particle effect are included in some of the prepackaged entities, such as fireworks that play when the goldfish cross the line. I believe this is the materials. Let's take a look. And we have different materials here. And this is the firework animation particle that we see when the goldfish finishes. All right, let's take a look at the app before we check out this next piece in build slide pieces in Reality Composer. All right, so before we build slide pieces in Reality Composer Pro, let's take a look at the app and let's run it. Here we have our app, we push play, and we get our simulator, and I have recreated a little bit of the left turn and the loop-de-loop. Something I find to be very interesting is that it looks like everything is extremely dark. This is the wood piece, as you can see. Let me go zoom in. It's a wood piece. This is the metal, this is the plastic, and this is the wood piece. All right, this is plastic, this is the purple plastic, and this is the metal silver metal. All right, so this is exactly the same as our demo here, but everything is lit up here in the demo. In my case here, in my simulator, everything's very, very dark. I have tried to place this in a very well-lit area. All right, so I'm gonna move this right by the window this time, and I don't think that's gonna make a difference. All right, so this is select all, and we're gonna move it right by the window. All right, this is right by the light source. I don't think that's changing anything. All right, let me just rotate this a little bit and let's zoom in. Okay, here we go. Here's what we got. It's dark. It's really, really dark. I don't know how they got the light to go, but it is what it is. So that's what we're working with. Let me pull this over. And while we work with this, and let's start the ride. Here, we have the goldfish. It's gonna swirl around, but the water is not even blue. And we have this gray water that's flowing through for some reason. And it goes into this tub of slightly blue water. I'm not entirely sure why that is the case, but this is what we're working with. And we'll go from there. Alright, onward to build slide pieces in Reality Composer Pro. Slide pieces are the building blocks of Swift Splash. The Reality Composer project contains a separate scene for each one. In addition to the 3D model that makes up the slide piece, each scene contains a number of other entities the app uses to animate and place the slide pieces. Here we have a couple slide pieces in our Reality Composer Pro, and let's pull it up. So we go to our Xcode beta, we come down to our packages, and we hit open in Reality Composer Pro. Here we have a few of our fish splash. Here's the fish, ending particles. Let's pull up a different piece. Let's say we were pulling up, let's see what piece they were pulling up. This is slide number 2. All right, let's take a look at slide number 2. Here's we go. Here's slide number 2. Let's rotate it around so that we get the same scene. Let's here we go. I believe it's like that, and we have some zoom in action here going. That's the pointer. This is zoom in. So okay, there we go. All right, very cool. And that's the water flowing. It's very well lit here. Okay, this is somewhat what we have. This is the Adventure Fish Slide 2 Glass Ride Animation. Adventure Slide Glass Animation. Let's pull this, make sure that we have the right one going. We have a play button, and that's the fish. That's where the fish goes. Very cool. Okay. In the hierarchy view, on the left side of the screenshot above, this is our hierarchy view. There are 2 transform entities called connect in and connect out. Where is that? All right, connect in, connect out in our entity. These transform marks the point where the slide piece connects to the next or previous piece. Swift Splash uses these transforms to place new pieces at the end of the existing slide, as well as snap pieces to other slide pieces when you manually move them near each other. Slide pieces demonstrate the 2 primary mechanisms Swift Splash uses to find entities at runtime. For some entities, such as connect in, Swift Splash uses a naming convention and retrieves the entity by name and suffix when it needs to use them. In other cases, such as when names aren't unique or the retrieving code needs configuration values, Swift Splash uses a custom component to mark and retrieve entities. For example, animated entities that appear when the ride runs contain a component called Ride Animation Component. The app uses this component to determine if the entity is an animation that plays while the ride is running. The component also stores additional states the app needs to implement the ride animation, such as a property called duration that specifies when to start the animation on the next connected slide piece. Ride animation components also include a property called isPersistent, Persistent ride animations stay visible at all times, but only animates when the ride is running, such as the animated door on the start piece. Non-persistent ride animations, such as the fish swimming through a slide piece, displays only when the ride is running and the fish is swimming through that particular piece. There's a lot to unpack here in this section. We let's take a look at that connect in and connect out. These, I don't know exactly what's going on here, what these are. In the inspector here, they seem to be just nothing. There just seems to be a point that's been designated as connect in and out. There's some sort of vectors here, and we have a ride animation component. As you can see here, I don't know how that's created, but this is not persistent and has a duration of 1.5 seconds. Right. So that's as much as I can see about this piece from this information here, but there is a lot to dig into here to make sure our ride works or to create. All right. Next, we have avoid duplicate materials with material references. Many of Splish Splash slide pieces use the same material. For example, the shader graph material that changes pieces from metal to wood to plastic is shared by all but one of the slide piece. To avoid having duplicate copies of each material, Swift Splash leverages USD material reference to share material between multiple entities in multiple scenes. The Reality Composer Pro project contains a separate scene for each shared material, containing only that one material. Other track pieces create references to that material. If you change the original material, it affects all the entities that references it. For example, a scene called M Rainbow Light USD-A contains the material M Rainbow Lights, and both starting pieces and ending pieces reference that material. Let's see that in action. Let's pull up the start and end piece. Here you can see a filter in your project browser, and we can get the end piece right here. And that opens up the end piece, and we can get the start piece right there. And in both these pieces, we should see a M underscore rainbow lights. That's what we're looking at right here, the M rainbow lights. And it references this M rainbow lights piece here. And the same with the start piece, M rainbow lights. As you can see, the same piece is used in both the start and end piece. Right. How it is used, I'm not exactly sure, but it's in there. And I believe it probably pulls it in somewhere in the code, somewhere. Is this a shader graph? Oh my goodness, that is a shader graph. And that's how it looks. Let's see. Well, there's a lot to look into here. And there's a lot to learn, but let's keep on learning what we are given here in the documentation. Parallelize the asset load to maximize load speed and make the most efficient use of available compute resources. Swift Splash parallelizes loading scenes from Reality Composer project using a task group. The app creates a separate task for each of the scenes it needs to load. All right, looks like we have an await with task group, load results, task group, and there's a logger info for piece in pieces, task group.add, and we add each piece from our Reality Composer Pro that we need to add. And then we are going to do a load results of this particular piece. And this loads everything in parallel with a task group. interesting. The app then uses a async iterator to wait for and receive the results for await results in task group. And we get if piece equals piece.filter, raw value equals key, and we generate these collision shapes and set up the animation visibility, set up connectability. Okay, for more information on task group, see concurrency in Swift programming language. Each of these pieces act as a template. When the player adds a new piece of that type, the app clones the piece and loads from the Reality Composer Pro and adds the clone to the scene. Wow, that is some interesting code. We can look into the concurrency in the Swift programming language to parallelize our loading of objects into our scenes. Uh, so let's take a look at this piece of code with task group inside our code and go from there. Let's see what we can learn. So first of all, let's find a piece of code. Contains with task group, enter. That's it right there. Okay, it's in our extension app state, and this is how we load pieces with a task group, and we await the results in the task group, and we load each piece. Very good. Well, I think there's a lot to look into here with this code, and we are going to look into it later, as we are I think that when we need to learn how to do this on our own, when we need to do it, we can reference this, and that would be super helpful. All right, specify sort ordering for transparent entities. When multiple entities have more than one overlapping non-opaque material, RealityKit default depth sorting can cause it to draw those entities in the wrong order. As a result, some entities may not be visible from a certain angle or in certain positions relative to other transparent entities. The default depth sorting is based on the center of the entity's bounding box, which may result in incorrect drawing order when there are multiple overlapping materials with any amount of transparency. You can see an example of this by looking at the start piece in Reality Composer Pro or by watching the video below. Oh, the water disappeared. Okay. The following video demonstrates the problem if the three boxes are the bounding box for three different transparent entities, and the small sphere are the box center, and the sphere that's closest to the camera changes as the camera moves around the box, which changes the order that RealityKit default depth sorting algorithm draws them. Okay, so we first see 1, 2, and then 3, the water. And by moving our angle, we're gonna see the water first, and then the glass, and then the wait, sorry, the this inside and outside. Exactly, there's a bubble inside the bubble. Okay. Swift Splash assigns a model sort group component to each of the transparent entities to manually specify the relative depth sorting. To fix the transparent issue in the start piece in the video above, Swift Splash instructs the RealityKit to draw the opaque part of the fish first, its transparent goggles second, the water third, and glass bowl fourth. The selected glow shell last. Swift Splash does this by assigning a model sort group component to each of the overlapping entities using the same model sort group, but with a different order specified. Alright, so in a way, if you have the issue where we are losing items we can ensure that we're loading the items in a particular order that will force the transparent pieces to be visible from all angles. So here we have the function set entity draw order, and for each descendant, model entity, logged information, let the component of the group, and we do a set. Right, so where is this function used? Okay, let's look into the code actually. Make this easier for us. All right, enter. Let's take a look. So, looks like here is the piece of code. What's the color? It's right here. Handle it. All right, fair enough. And so, what about this one? Oh, okay. So this sets the order, and this adds this piece to each piece of the order, and we find this name model, and we add these orders to it. This is for the start piece entity, and we add each piece of it together in this particular group. So we start by fish idle, fish ride, glass, sort order, sort ordered glass, and the start glow name in that particular order. Very good. Next piece to this is traverse connected track pieces. The root entity for all of the individual pieces has a connectable component. This component, a custom component, marks the entity as one that can be connected or snapped to other connectable entities. At runtime, the app adds a connectable state component to each slide piece it adds. The component stores state information for the track piece that does not need to be edited in Reality Composer Pro. Among the state information that this component stores is a reference to the next and previous piece. Was it okay? So it's connected. To iterate through the entire ride, ignore any disconnect pieces. The app gets a reference to the start piece, then iterates through until the next piece is nil. This iteration, similar to iterating a linked list, repeats many times throughout the app. One example is the function that calculates the duration of the build ride by iterating through the individual pieces and adding up the durations of the animations. So with this piece of code, we can learn about how every piece is connected. Let's look at that in the code. Calculated ride. All right, this is a public function in app states. So here's a start piece, here's next piece, and here's a time interval. While piece is not nil, like a linked list, our longest animation, time interval, next piece for each descendant, and get the duration, add the duration, try to get the next piece in the connectable state component dot next piece, and so on and so forth. Yes, very good. Now, interact with the ride. To build and edit the ride, players interact with the Swift Splash in different ways. They interact with Swift UI window to perform certain tasks, such as adding a new piece, deleting an existing piece of the ride. They also manipulate slide pieces using standard VisionOS gestures, including tap, double tap, drag, and rotate. The player taps on a piece to select or deselect it. When the player double taps a piece, they select the piece without deselecting any other selected pieces. When someone drags the piece, it moves across the immersive space, snaps together with the other piece if placed near one. Two-finger rotate gesture spins the selected track paste on the x-axis. I think all of us has probably done this before. We just add the piece, delete the piece, click the piece and click the delete button. Rotate the piece. Alright. Oh, you just rotate it. Alright, very cool. And the drag, we have done that before. Swift Splash handles all of these interactions using standard SwiftUI gestures targeted to an entity. To support any of these gestures at any time, the app declares the simultaneous gesture. The code for all of the gestures are contained in Track Building View, which controls the app's immersive space. Here's how the app defines the rotation gesture. Alright, so we're going to target any entity on change value, app.phase equals building track, phase, place starting piece, dragging piece, and handle rotation. On end, it does opposite, and handle rotation change is ended. True. Okay. Very interesting. So this is how we handle gestures. Here is the simultaneous gesture. I'm sure we can find all the other gestures as well. We have a gesture, drag gesture here. We have a rotation gesture. We have a tap gesture. And we have a single tap gesture. And what we're going to do based on this particular action that we take based on our gesture. All right, so that's how gestures are included in the app. Because multiple tap gestures on the same reality view executes with a different number of taps, multiple gestures may be called at once. If a player double taps an entity, for example, both the single tap and the double tap gesture code gets called. The app has to determine which one to execute. Swift Splash makes this determination by using a Boolean state variable. If a player single taps, it sets the variable called should single tap to be true. Then it waits for a period of time before executing the rest of the code. If should single tap get set to false while waiting, the code doesn't execute. When Swift Splash detects a double tap gesture, it should set should single tap to be false and preventing a single tap code from firing when it's executed the double tap code. So everything's very state-based. Here we have our tap gesture on end and should single tap to be true, and we should also see it to be false a little later in the double tap. As we can scroll through the code, because we can, and it should single tap should be equal to false, and it is false indeed. And with that, we have gone over every step of this particular coding sample. That was very cool. I really enjoyed that. There's so much to dig into here, so much to learn, so much to analyze more deeply when building your app. How to use gestures, how to demarcate what sort of gesture to use, and how to, make sure you're using the right gesture for the right movement. We learned about connecting items together, building the duration, setting a particular order for transparent entities. We did a parallelizing the asset load to make things faster. Very cool. We avoided duplicate materials with material referencing. And there's just so many optimizations done here, and building slide pieces in Reality Composer Pro. Of course, we did not go into the details, the very deep details in each of these, which would be even cooler. I think we'll have a chance to do that later. When we when we're building our app, we'll dig into it more deeply and understand how each piece connects to one another, and so that we can build similar applications. All right, with that, I'll see you in the next one.